So today we're going to add our third form, which is point slope form. Point slope form has a general form just like all of the other ones. It's just longer. Good news is that, remember how last trimester on your final exam you had that reference sheet photocopied on one side? And all of those formulas didn't really make a whole lot of sense? Point slope form is on here, okay, as a standard form and slope-intercept form. So it's not something that you have to have memorized. I pretty much guarantee you will have it memorized after we get through the next unit as well. Okay, point slope form says y minus y sub 1 equals m times x minus x sub 1. It's weird. Now, it isn't just completely random. So the old dead men did actually have a reasoning.
Is that y1?
Y sub 1. Okay, and what is the formula for slope? Y2. Guys, up here, please.
Divided by y1.
Guys, up here, please. Right? Do we agree that this is our slope formula? Do we also agree that if I were to put m over 1, you don't need to write this down, remember, write stuff over here on the whiteboard, you don't need to write down. If I were to put m over 1, this then creates two fractions being set equal to each other. And we've talked about how with proportions we can cross multiply. And so if we cross multiply, we have y2 minus y1 equals m times x2 minus x1, which looks exactly like our point slope formula. Okay, the only difference is that we won't have 2 points, which is why we don't see that sub 2 on these. Okay, this x and y right here, these will stay as x and y. There won't be a number plugged in for them.
So would that be just 0 then?
No, it'll just look just like in y equals mx plus b, this x and y we see, that x and y we will still see. They will just look like x and y. Okay, point slope form. Point slope form. What 2 things do we think we're going to find? A point and a slope. Now, one of them should be pretty obvious to us. What is going to be slope in this formula? M. Right? So our slope is right here in front of the parentheses. The point starts to get weirder. Okay? The point is made up of these 2 things. Okay? Where an ordered pair is always an x, comma, y. So this is backwards. The x goes first, but it's at the end of the formula. The y goes second, but it's at the beginning of the formula. And if that wasn't weird enough, we also have to take the opposite sign. If it's positive, make it negative. If it's negative, make it positive. Now, we know that we can read this symbol right here as a subtraction. We also know that we can read this as a negative. We can also read it in a formula as the opposite of, which is why we have to take the opposite sign. So if it looks negative, we'll write it as a positive. And if it looks positive, we will write it as a negative. Everything about this point is backwards. It's just all backwards. Okay, so we're going to look at a couple examples here. So if we were given y minus 3 equals 1/2 times x minus 5. What would we say the slope is?
1/2.
M equals 1/2. Can we agree with that statement?
Yes.
It's the number in front of the parentheses. Okay, so now the point, right? We know a point has to be an ordered pair, so we definitely need that formatting. What's our x value going to be?
-3.
That's our y, because right, it's all backwards. It's all backwards. So we're looking over here.
-5. Or
It looks negative, so we are going to
Positive.
write this as a positive.
So 5.
Wait, why would you write it?
5 and -3.
No,
Or
positive 3.
5
Positive
and
3.
I know, right? My students did the same thing first period and they're like, oh my gosh, this is all backwards. By the end of, we're gonna do a little short activity here. It'll be fine. It's just getting that in our brain. The reason why it's opposite, okay, my students usually are okay with this statement.
So this is the y.
If we were to plug into, for example, the slope formula, something like 2 comma -3 and -4 comma -5, right? We say y, I don't need to write it down. We say -5 minus -3, and these two negatives become a positive. So even though it was a -3 here, it looks like a +3 down here because that double negative turns into addition. That same thing happens up here, right? This subtraction sign is part of the formula, not part of the number that we're plugging in. So then when I plug in -4 minus 2, right, this was a +2, but it looks like a subtraction in front of it down here. That same idea happens in point slope form. So it all just seems backwards because subtraction is also the opposite of.
Wait, so if those are positive,
Yep, so then let's look at another one. What if we say y plus 7 equals negative parenthesis x plus 2? What's our slope going to equal? -1. Okay, the slope is the one we have to be kind of like cling to. I definitely know what the slope is. Check that one off first.
Negative.
So
Negative.
-2,
7.
-7. Completely backwards, right? Switch which side they're on and change their signs. Y plus 5 equals x minus 3. What does m equal? Which is it? Is it a 0 or is it a 1?
0.
Oh,
Why would negative?
Okay, so we have to think way back in our brains. Way, way, way back. Like maybe the 3rd day of the school year. Remember when we learned things like commutative, associative, distributive type of properties? And we also talked about an identity property. And my students are all kind of like, whatever, I can learn these, but they're dumb. Why do I need to know them? These are why, okay? When a number is missing through multiplication, how is this 1 attached to all of this? Multiplication. When a number is missed in multiplication, the identity property of multiplication says fill it in with a 1. Okay, so this is a 1.
Negative.
What's, no, because we don't take the opposite of that one.
Oh, okay.
So 3.
So 3 and then -5.
Yep.
The only one I missed was the negative.
Right, because we, again,
Yeah.
this is why point slope form is very finicky, because you can take the opposite of some, but don't take the opposite of others, and make sure you flip which side they're on at in the formula, and let's not even talk about graphing yet. Graphing's not hard, it's It's weird. It's just weird. They're just pieces that seem backwards from what we normally know. Okay, what if I say this though? Y plus 3 equals 2 times x. What does that equal?
1.
2.
Does that mean that that
Oh,
point
yeah,
is 0?
I didn't see it.
-1 would it be? -1, or would it be 0?
So it sounds like we're okay with this one being a -3.
Yes.
Check.
-3, yeah.
What number is missing here?
Mm,
Okay, so is it missing through addition or is it missing through multiplication?
Multiplication.
Bless you.
Addition or subtraction? Because the formula says we want to be subtracting something off. So the additive identity, right? The identity of addition is that if a number is missing through addition or subtraction, we fill that in
With a 0.
with a 0.
So it's just.
So it's just.
So this is 0, right? Because negative or positive 0 is irrelevant. Oh, I broke my rubber band. Bummer. Okay, when we're looking at this, it's almost exactly the same as graphing in slope-intercept form. The catch is that we have a point that we plot as x, comma, y, and we have a slope that we have to count as y over x. Right, that is a little bit annoying,
So this is.
but
This is Y and X.
right, we got both of them going on in this one. We have both. Okay, so if we want to graph in point slope form, so let's say we want to graph y minus 3 equals 1/2 times x plus 4. Okay, our very first step is going to be very similar to our first step when we were graphing in slope-intercept form. Our first step is going to be to find our slope and our point, which is what we were just practicing. So that hopefully when we go to find our point and slope, it's just a really quick, we look at it and we can find it. Okay, so we should all know at this point, since we all just said we were okay with practicing, what does m equal?
1/2.
And what is our point?
-4/3.
Okay, so hopefully that's just a quick check where we're able to find that out. Okay, our second step, which is the same as slope-intercept form, is going to be to write the slope, so write our slope as a fraction. And just like in slope-intercept form, sometimes we're in luck and it's already given to us as a fraction. Sometimes we're not in luck and we will have to turn it into a fraction.
So this one we have to turn in, or is it already?
Well, what is our slope on this one?
Oh, 1/2.
1/2.
It's already-
So we already have a fraction. Yep. Step 3. Very similar to slope-intercept form, except now instead of plotting a y-intercept, we are going to be plotting a point. So we are going to plot the ordered pair, -4, +3. So x, comma, y, -4,
And then.
+3.
So
It's It's not on the intercept this time, right? We don't know what the intercept is. We just know a point.
So it's just 1 point.
So it's just one, well, right now it's just 1 point. Mhm.
And then you go.
Oh, then you count, right, okay. So you count 1 up and then 2 right.
Right? So then we're going to do the exact same thing that we've been doing with slope by counting rise over
Now I'm starting
run.
to get this.
But now we're counting from the point.
So it's
Not from an intercept, not from the origin. So from this point,
over 1 up 2.
yeah, that's the dilemma. We can't go backwards. It's up 1
Up 1.
over 2. You're like, darn it, why did I flip that?
Why?
Well, you flipped it because you plotted the point over 4 up 3. Right? Those are flip-flopped orders of what we do first.
Oh, now I'm
So we slope, we rise 1, we run 2. Rise 1, run 2.
We practice one on the mark.
We are going to practice a few of these. I know it's like, oh my gosh, we're almost out of time, but these don't take too long.
There's 3 minutes left.
We actually have 4 minutes left, so we got time.